All right, welcome to The Explainer. Today, we're going to dive into a problem that, let's be honest, drives every developer crazy. We'll use a pretty simple analogy. Think of a fast car, an open highway, and a very, very slow inspector.
So, have you ever had this happen? You've got an app, it's supposed to be lightning fast, right? But the second you try to see what it's doing, maybe you attach a debugger, the whole thing just grinds to a halt. It's like, why does just looking at something slow it down so much? That's the big mystery we're going to crack today.
Okay, so let's set the scene. Our application is basically this high-performance machine, and it has one very simple job.
All it wants to do is deliver its package, its data, from point A to point B, and it wants to do it as fast as humanly, computationally possible. We're talking clear skies, empty roads, just pure, unadulterated speed. That's our starting point. This is what we should be getting.
Okay, so to figure out where it all goes wrong, we need to meet the players in this little drama. We're going to imagine this whole thing as a road trip down a highway. First up, our hero, the car. And look, this is not your grandma's sedan. This is a sleek, powerful sports car. It's our application, right? Built for one thing, speed and efficiency. All it cares about is making that delivery we just mentioned.
All right, next on our highway, we've got the toll booth. You can think of this as the OS kernel. And in a perfect world, this thing is totally automated. The car just zips through, the gate goes up, no big deal. It's a checkpoint, sure, but it's supposed to be super fast.
And then there's this guy, the inspector. This is where our whole mystery comes from. He represents a debugging tool, something like strace, which uses a system called ptrace. And unlike our automated toll booth, he is very, very manual. We're talking clipboard, pen, maybe a cup of coffee. He's in no hurry. And when you know it, he's decided to set up his little inspection station right at our super fast toll booth.
So, what do you think happens when our incredibly fast car runs into our incredibly slow inspector? Well, we get stuck in what I like to call the inspection loop. And trust me, this is where that beautiful dream of high performance turns into a real traffic nightmare.
Yeah, look at this. This whole sequence, this is the journey. Instead of just zooming through, passing the toll booth, is now this ridiculously complicated dance that just crushes performance. Let's break it down.
Okay, step one. Our sports car is just flying, eating up the miles, and then bam, screeching halt, a red light. Our application has to slam on the brakes and stop dead in its tracks. In the real world, this is what happens every time it makes a system call, which is basically a request to the kernel for help.
So the car's stopped, engine's just idling there, but does the inspection start? Nope, not yet. First, the toll booth has to send a signal over to the inspector, who, is probably off drinking coffee somewhere. This whole delay, that's what we call a context switch. The system literally has to pause our app just to wake up the debugger.
Finally, the inspector moseys on over. He leans in the window and starts his whole paperwork routine, checking the ID, looking at the package details, writing every single thing down. And our poor little sports car, it's just sitting there, burning fuel, going nowhere. Okay, so finally the inspector gives the nod. The car gets to do its job for like a nanosecond. The toll gate lifts, the package is processed, but the very instant it's done, bam, another red light. Can you believe it? The car just started to roll, and now it has to slam the brakes on again. This is the exit of the system call.
And who do you think shows up again? Yep, our favorite inspector. He walks back over, this time to check if the delivery was successful, print out a receipt, more paperwork. It's just this agonizing cycle. Stop, wait, inspect, go for a tiny bit, and then stop all over again. All for one single operation. So here's the kicker, the reality of the situation. Our super fast sports car is spending almost zero time actually driving. Instead, it's just stuck at red lights, waiting and waiting for this inspector to finish his paperwork. The amount of go time is just a tiny sliver compared to all the stop time.
So let's talk numbers. What is the true cost of all this waiting? I mean, how much time are we really throwing away here?
Well, this chart lays it all out. It's pretty brutal. That little sliver on the left, that's the time our car is actually driving, doing its job. The rest of it, that huge, overwhelming chunk, a whopping 85%, that's just time spent waiting for the inspector.
And this really sums it up perfectly. The car spends way more time stopping for the inspector than it does actually driving. That's the whole reason ptrace causes so much latency. The problem isn't the work, It's the waiting.
Okay, so it's a fun story, but why does this highway analogy actually matter? Let's peel back the metaphor and connect all these dots to what's really happening inside your computer.
So here's the one-to-one translation. Every single time our car stops and starts, that's a context switch between your app and the debugger. Our inspector, obviously, is that strace tool using the ptrace mechanism. And all that waiting around, all that metaphorical paperwork, that creates this massive performance overhead. And get this, for every single system call your app makes, it has to go through this whole painful process not once, but twice. Once on the way in and once on the way out.
So now you get it. You see the true, staggering costs of this old way of observing things. It takes a process that's built for speed and forces it into this agonizing stop-and-go traffic jam. And that leaves us with a really important question. What if we didn't have to stop the car at all? What if the inspection could happen while the car is still flying down the highway at 60 miles an hour? That's the fundamental question that's pushing the whole next generation of observability tools forward. Because finding a way to inspect without stopping, well, that changes everything.